Bismillahirrahmanirrahim. We continue our discussion in software engineering, and the chapter that we were discussing in previous lecture was software process and project metrics. We continue our discussion in this chapter and see what different types of software process and project metrics are available to be used by a software development organization. Let's first see the agenda items and have a recap of what we had already discussed within this chapter and what other topics that we need to discuss in today's lecture. In previous lecture, we have discussed the importance of measurement within any project. We said that measurement is very fundamental and important within any engineering discipline, including software engineering. It mainly helps software engineer and the software organization to gain insight by providing some techniques for the evaluation of the objectives set for the said project. Software metrics, as we had discussed, actually represents a wide range of measurements and the techniques for measurement for the software process and also the objectives or the project overall. Mainly, the measurements are applied to bring improvement not only within the software process, but also the improvement is sought within the individual efforts and also the software project as a whole. The performance of individual is important when we are carrying out some software project. So software metrics or the measurements, the techniques that help to measure the software quality, the software process, and the software project also helps in the evaluation of an individual's performance within the software development project. These metrics or these measures do not intend to degrade an individual basically, rather they help to motivate an individual in improving their performance. The measurements for individual performance are generally kept private and is only known to the management and to that particular individual. While the project metrics and the process metrics, the software process metrics are generally public and are known to all the teams working on some software project along with the management of the organization. This collectively helps in improving the overall performance of the software development process and the project that is being done at the time. Generally, project measurements are taken and compared with the previous similar projects done in past in order to understand if the project improvement has been happened or not. The positive attributes and the negative attributes are noted down in order to highlight where improvements are required. So in previous lecture, we discussed the difference between the matrix and measures, and what is the indicator. So indicators are mainly the improvement points that requires attention. These are the indicators. For example, that can be the performance of an individual, that can be improvement in some particular phase in the software development process. Then we discussed why matrix is important within the software process and also within the project overall. What is the importance of matrix or measurements within the software process? There comes the performance evaluation of an individual, and how the project domain, the measurement is important within the project domain, where we compare the current project with the performance of past similar projects. So both the performances of two similar and even two different projects are compared in order to get some indicators. These were the points that we had already discussed in the previous lecture. In today's discussion, we are going to discuss software measurement and see what parameters or what metrics are used to measure software. The main intention basically here is to measure the quality of software. But as I had said in previous lecture, that software quality is quite detailed topic, and we are going to discuss software quality and the indicators or the metrics used to measure the quality of software in a separate chapter. So there are different metrics to measure software quality, and we'll be discussing them later on in a separate chapter. But here, what metrics generally are used within software industry to measure the software? They also intend to measure the quality of the software, but the quality attributes are little more different than other parameters, which we'll be discussing later on. Let's proceed with the discussion on today's topic, that is software measurement, and see what common metrics are used within software industry to measure a software. Measurement within the physical world are generally categorized in two ways, and within the software domain they are also categorized in two forms. One is known as the direct measurement, while the other is known as the indirect measurement. These two types of measurements are generally done within the real world in any field. Some things are measured directly, while some factors or some things are measured indirectly. The direct measures, for example, the length of some road, the length of some cloth, and the other is the indirect measures, for example, the quality of the road, the quality of the cloth. So these are two different types of measures. So we categorize software measurements similarly. Some factors can be measured directly, while some factors can be measured indirectly. The direct measures of the software engineering process generally includes the cost and efforts being used to develop some software. So these are some factors that can be measured directly. Direct measures of the software product also includes the line of code produced, the execution speed, the memory size, the defects generated by or the defects reported by the customer or the defects highlighted by the programmer, etc. While the indirect measures of software product generally include different factors such as the functionality of the software quality, while quality, as I just said, is quite a vague term. It includes different aspects and we'll be discussing that separately. Indirect measures or indirect metrics also include the complexity of a software, how complex a software is to be installed, to be used by specific customer, the efficiency of the software, the time it takes to generate results is the efficiency, the reliability of the software, maintainability, and many more such things which cannot be measured directly. Rather, they are observed either by the software development team or by the customer. The cost and effort required to build software, the number of lines of codes generated, and all other direct measures are quite easy to be collected as long as the specific conventions for measurement are there already within the organization. If there are some set rules to measure these direct parameters such as the line of code, the cost incurred on the project, the efforts to be in placed by every individual working in the software project. So if a company has some parameters, some defined rules to measure these direct factors, so it becomes quite easy for the project team and the management to measure every individual aspect directly. However, the quality and the functionality or the indirect measures of software are quite difficult to be assessed and can be measured only indirectly. You have no specific parameter to measure the functionality of software, to measure the quality of software, to measure its complexity. So there are no specific metrics or no specific parameter to have a gauge of these features of a software. So these features are generally then measured indirectly. Individuals are often combined to develop software projects that are public to a software team. Project metrics are then consolidated to create process metrics that are public to the software organization in general. In order to measure software product, generally different techniques are used, and the common one is known as the size-oriented metrics. Size-oriented metrics are the common metrics, but they are not well recognized or well accepted by the software industry as a whole. So the size-oriented metrics are mainly derived by normalizing quality and productivity measures by considering the size of the software to be produced. So here, generally we take into consideration the size of the software to be generated, and the unit in which it is measured is known as log. the line of code, it is used as generally the normalization value. Size-oriented metrics are the direct measures of software, where an organization builds a simple record of size measures for the software projects. It is generally built on past experiences of organizations. So it is the smallest matrix used for computer programs to measure the size, and it is very easy to be measured. Any normal programmer can measure the size of its program which he is developing. So size-oriented matrix is mainly used to measure and compare the productivity of programmers. Line of code is computed in the size-oriented matrix. The line of code is defined as one line of code or one line of text within the source file. So this is a very common matrix used for software measurement. So they are mainly used to compare the performance of different programmers. One who develops a code within less number of lines of codes, while the other who develops a code with quite a lot of number of lines of code. So this basically helps in measuring the performance of different programmers. Size-oriented metrics are not universally accepted. As I just said, these software measurement metrics are not accepted universally within the software industry. So this is generally considered as not one of the best ways to measure the process of software development. The opposites of, or the people who do not accept this technique, claim that line of code is an artifact of all software development projects that can easily be counted, that many existing software estimation models use line of code as the major input, and the large body of literature and data predicted on line of code is already available. While on the other hand, the people who oppose line of code also claim that log measures are majorly programming language dependent, as they penalize well-designed but shorter programs, that they are or they cannot be easily accommodated on non-procedural languages. So some people accept this technique while some people oppose this. The opposition are of the opinion that the log mainly depends on the programming tool being used. So some programming tools such as the procedural languages help a user to limit their line of code, while the non-procedural languages, they do not provide such facilities. While the people who appreciate or follow this technique are of the opinion that log is the major input criteria to be measured within any organization, and its use is widely available within the literature, and it is quite easy to be measured. Even an individual programmer can measure his performance by counting the line of codes within his source file. So some people are in the favor of this technique, while some people reject this technique as it may not be the best technique to measure the software. So then there is another software measurement matrix which is also generally or commonly applied on software. That metric is known as function-oriented metrics. Function-oriented software metrics use a measure of the functionality delivered by the application as the normalization value. So here, the measure of functionality, how much functions have been generated by specific software, is used as the normalization value. In log or in size-oriented metrics, we used line of code as normalization value, while in function-oriented metrics, the functions generated or provided by the software is used as the normalization value. Since functionality cannot be measured directly, so it must be derived indirectly using some direct measures. So functionality, as we said previously, is a factor within software which cannot be measured directly. How much functionality or how much functions are provided by a software to a customer, this cannot be measured directly. So this is an indirect measurement technique which can be used or which can be measured using some direct matrix. So we can say the function point is a unit of measurement to express the amount of business functionality which a software is going to provide to its users. So it is basically the measurement or the unit of measurement of the functionality that the software is going to provide to its users. It also measures the software size. So the more the function a software has, the more the size of a software will be. So indirectly, it also measures the size of the software. Generally, here the functions within a software are quantified in terms of how meaningful they are to users. So there are different types of functions within a software. Some functions may be useful to some users, while other functions may not be as much useful to other users as they are for some different set of users. So the function-oriented metrics are generally quantified on the usage of functions or the usage of software functionality, how much usable or how much functional it is to a specific target set of users. Function point considers the number of functions being developed based on the requirements specifications. So how many functions that have been requested by the customer are being provided within the software. So function oriented matrix or function point mainly measures that. So it may happen that all the requirements may not be incorporated within the functionality of the software, or they may be added time to time. They may not be added at once. So in that case, the functionality of the software, while it was released for the first time, may be that appropriate, or maybe may not be that functional to user, while later on the more requested functions are when added to the software, the more they become functional to the user. So function point matrix is an ongoing metric or an ongoing measure. If the software is being developed in prototypes or in models, so the initial or the trial version or the first version of software may be not as functional as the final version of the software may be to its customers. So this matrix is an ongoing measurement technique which throughout the software project life is applied whenever a new functionality is added to the software. Keep in mind the functionalities are more dependent on user requirements, while some of the functions are generally not told by the customer, as they are understood that they should be present in the software. So we generally, within the function-oriented matrix, we measure those functions which have been requested by the customer in order to make it more functional to the said user. The next point that we are going to discuss after discussing different metrics for software measurement, now we have to see how we can integrate these metrics within software engineering process. The process we had already discussed. What is a process? It is actually the sequence of steps to design, to develop, and to implement a software. So different metrics, as we just discussed, are there. So how we can integrate those metrics within a software development process. As I said in the previous slide, that majority of the software developers still do not want to measure their performance. They do not want to measure the software development process, and they do not want to be judged on the basis of their performance. So the different metrics that we just discussed are not universally accepted and adopted for the same reasons. Still, if we observe the development mechanism that is being carried out within the software development world, the software engineers still have very less or no desire to start measuring their own performance or the software process as a whole. So it is quite difficult to have an attempt to collect data when the past projects were never being assessed. So generally, a resistance is observed by the software management or the software managers from the software development teams, the software engineers. They generally ask, why do we need to measure? Why there is a need to assess the performance of people working on a software project when in past we do not find any such example. So the software managers and or the management of software organization generally face this sort of resistance, and they observe complaints on behalf of the software workers. Now the question is, why is it so important to measure the software process and the software product as a whole? The answer is quite obvious. If we do not measure, so there will be no way to determine if we are improving or not. So if you want to bring improvement, you must measure different aspects of the software process and the project as a whole. This will help to compare projects with the past projects already being carried out by the software company. But if we are not improving, that means the company is going in loss. By requesting and evaluating productivity and quality measures, senior management can establish meaningful goals for the improvement of the software engineering process. The day-to-day rigors of software project work have little time for strategic thinking, as software development task is in itself a very quite heavy task. So it is the software managers get very little time to plan strategically. Software project managers are mainly concerned with more work, but equally important, they are to handle the issues. And the issues are developing meaningful project estimates. The cost is dependent on the performance of software process and the individuals working on it. The time is dependent on the software development process and the people working on that particular project. So in order to make meaningful estimates for the project, it is very important for the software manager to have metrics in place for the measurement of the overall process and the product. By using measurement to establish a project baseline, all the issues related to the project and the product becomes very manageable well in time. We have already noted that the baseline serves as the basis for estimation. Additionally, the collection of quality metrics enables an organization to tune its software development process in order to remove the few causes of defects that have the greatest impact on the software development process and the product as a whole. So this will help refining or tuning the performance of not only the individuals but also the process that is being used to develop some software. So fine-tuning of the capabilities is only possible if we are having some metrics or parameters to measure the software process, the project overall, and the end product, which is the software. Generally, metrics are designed by organizations themselves. Since there are no universally accepted or adopted metrics available within the software industry, so every organization have some parameters to measure the performance of software engineering team, the software development process, the software project, and the end result. It is advised for organizations to start from simple metrics, like to have some rules and regulations for the measurement of the performance of individuals and the software process that is being carried out to develop a software. Unless and until there are set guidelines or baseline for the measurement of performances, the individuals are never open to accept the change. In order to bring improvement in their performance, it is very important to have in place the guidelines, the baselines, or the rules and regulations on how or when their performances will be measured against what parameters. This will bring a sense of improvement within the software development team, along with the incentives to be offered by the organization, as incentives also further enhance the improvement within the individual efforts. That is all for now. This is the end of the chapter Software Process and Project Metrics. In this chapter, we had discussed the importance and value of software measurement and the metrics that have been used in different sectors of the software development industry. Ultimately, the main intention of these metrics and measures is to have the improvement indicators where the improvement within the software process, the project, and the software and product is required. If the improvement is in place well in time, the software development process will bring much better results, as we can say the fruitful result or the functionality of this end product will be enhanced to the customers. That is all for now. I thank you all.